Good evening, students. Today our topic is some quantities associated with the Bohr's orbit. Okay, already last class we discussed about some quantities associated with the Bohr's orbit, radius of orbits, velocity of resolving electrons, orbital frequency. Okay, so we discussed some topics, some quantities associated with the Bohr's orbit. Okay, so today we'll discuss about remaining quantities associated with the Bohr's orbit. Okay, so yesterday last class only we discussed about this orbital frequency of electron also. So today we'll discuss about electron energy, and today we'll discuss about electron energy and potential energy, kinetic energy, frequency of the emitted radiations. Okay, so frequency of the emitted radiations, frequency of the emitted radiations. Okay na. So and today we'll discuss about the electron energy levels in hydrogen atom, electron energy levels in the hydrogen atom. Okay, so let's start the class. So first, electron energy. So electron energy, nothing but electron has two types of energies. So electron is kinetic energy, potential energy. Okay, so electrons are moving around the nucleus. Already we know this is the nucleus, and electrons are moving or revolving around the nucleus. So due to the motion, electrons possess kinetic energy, and due to the place, due to the attraction, why we get potential energy means due to the attraction between electrons and the nucleus, so electrons possess the potential energy. Okay, once again I'm repeating same point. Electrons have two types of energies, kinetic energy and potential energy. We know that kinetic energy is nothing but so by virtue of motion. Okay, due to the motion, any body possesses the energy, that energy we call as a kinetic energy. And due to the potential energy, so what is mean potential energy? Due to the place, due to the state, some particles, some bodies possess energy, that energy we call as a potential energy. Or due to the attraction also, some bodies possess the energy, that energy we call as a potential energy. So that electrons possess two types of energies, kinetic energy and potential energies. Okay, first we will discuss about the kinetic energy. So already with the kinetic energy 1/2 mv square. V is the velocity, m is the mass of the electron. Already we know that the velocity of the electron, last class we discussed about the velocity. Just we substitute v value in this equation, we get the kinetic energy. Okay, so we get the kinetic energy. So next, so kinetic energy, the kinetic energy is nothing but this is the kinetic energy. And next one, potential energy. So potential energy, nothing but it is a fact due to the electrons lies in the field of positive nucleus. Okay, so due to the positive nucleus, some attraction forces acting between electrons and the nucleus. So that force, so due to that forces, electron possess the potential energy. Okay, so potential of the electron, already we know that E is E by 4 pi epsilon naught R. So R is the distance between electron and nucleus. The potential energy of the nucleus, electron is nothing but this is the potential energy of the electron. Okay, so this is the potential energy of the electron. So total energy nothing but kinetic energy and potential energy. Just we substitute the kinetic energy and potential energy. Okay, so kinetic energy and potential. So we should remember, we should compare potential and kinetic energy. So kinetic energy possesses positive charge. Okay, positive, but potential energy possesses negative sign, negative charge or negative sign. Why? So why this potential energy shows a negative sign is nothing but, so always negative sign. What is the meaning of negative sign? Okay, so here the negative energy is nothing but, so here so due to the attraction, okay, negative means due to the attraction only this potential energy develop, so that so this potential energy shows negative sign. Okay, so when we add this kinetic and potential energy, we get this total energy. So when we observe this total energy also, it possesses negative sign. What it means? Why this total energy shows negative sign. So it means, so this negative sign means, so here the negative sign mean is nothing but the magnitude of potential energy. The magnitude of potential energy is greater than kinetic energy. So that this total energy shows negative sign. Once again I am repeating same point. The magnitude of potential energy is greater than kinetic energy, so that this total energy shows negative sign. Okay, what it means? So why this potential energy is more is nothing but, so due to the potential energy. So when potential energy is more only, the electrons are not escaping from nucleus. So already we know the nucleus, electrons are moving around the nucleus. So potential energy, due to the potential energy, when potential energy is very high, so it means the electrons are not escaping from the nucleus. Okay, so that this negative sign, this is the meaning of the negative sign. Okay na? So this is the meaning of the negative sign. So this is the total energy formula. And the frequency of the emitted radiations. Frequency of the emitted radiations. So here already we know that point when electrons are moving higher energy level to lower energy level. Okay, this is a E1 energy level and E2 energy level. When electrons are jumping higher energy level to lower energy level, it emits the radiation. So according to Planck formula, so E2 minus E1 is nothing but H nu or NH nu. Okay, so here E2 minus En2 minus En1 is nothing but H nu. Okay, so En2 nothing but second orbital energy, En1 first orbital energy. Okay, just we substitute n is equal to 2. So when n is equal to, this is a En2 value. Okay, second orbital energy. When we substitute, when n is equal to 1, first orbital energy. This is a first orbital energy and second orbital energy. So finally we get, when we take the common, m e square m e power 4 by 8 epsilon r square h square. Okay, so we get the 1 by n1 square minus 1 by n2 square. Okay, so this is a frequency of the emitted radiation. So frequency is nothing but, it is represented by nu. Okay, not v. So we call it as nu frequency. So frequency is equal to this value. Okay, so from this, so we will calculate the lambda also. So we should remember the relation between frequency and lambda. Wavelength is equal to nu is equal to c by lambda. This is a basic formula we should remember. So nu is equal to c by lambda. Okay, so from this we can calculate the wavelength also. So we can calculate wavelength. So here c by lambda, nu is nothing but, we can write c by lambda, we can write c by lambda. So from this m e power 4 by 8 epsilon r square h cube, 1 by n1 square minus 1 by n2 square. Okay, from this we can write 1 by lambda is equal to this value. 1 by lambda is equal to this value. From this we can write, so here r is equal to this, this constant we call as the Rydberg constant. Okay, so this mv square m e power 4 by, so 8 epsilon square h cube c, this constant we call as a Rydberg constant. The value of this constant 10 into 10.97 into 10 power 6 meter inverse. Okay, so here once again, so here 1 by lambda is equal, we get this constant, this total term we can represent with the r. Okay, it represent with the r. Okay, so this r we call as a Rydberg constant. The value of Rydberg constant is nothing but, so this is a 10.97 to 10 power 6. Okay, so here 1 by lambda nothing but, so here 1 by lambda we call as the wave number. Okay, so we can represent with the wave number. 1 by lambda is nothing but a wave number. So wave number is represented by nu bar. Okay, so this is a general expression for the wave number. Okay, so these are the quantities associated with the Bohr's orbit. Okay, so last class we calculated some velocity, frequency. Okay, today we calculate total energy, kinetic energy, potential energy. Okay, and the wave number also we calculated. Okay, so next we will discuss about the electron energy levels in hydrogen atom. Okay, so hydrogen atom is nothing but 1 H1, first element, that is the hydrogen. We will calculate the energy levels in a hydrogen atom. Okay, so total energy, already we know this formula. Total energy me power minus me power 4 by 8 epsilon r square n square h square. Okay, the nth orbit total energy, already we know this. M is nothing but mass of the electron, 9.1 into 10 power minus 31. E charge 1.6 into 10 power minus 19 coulombs, and epsilon naught permittivity of free space 8.85 into 10 power minus 12. Okay, n is a orbital number, so n is nothing but orbital number. You should remember n is nothing but principal quantum number or orbital number. Okay, so orbital number. So next h is Planck constant, 6.625 into 10 power minus 34. When you substitute all these values, we can get this value. Okay, we can convert this value joules into electron volt. Okay, if we convert this one into electron volt, we get this formula. So the total energy is nothing but minus 13.6 by n square electron volt. Okay, this formula is very important, we should remember. So total energy of hydrogen atom is nothing but E is equal to minus 13.6 electron volt by n square. Here what is n? N is nothing but principal quantum number or orbital number. We can substitute. If n is equal to 1, this it shows the first orbital energy. If n is equal to second orbital energy, so n is nothing but orbital quantum number, principal quantum number or orbital number. Okay, if n is equal to 1, we get this value, minus 13.6 electron volt. If n is equal to, we get that minus 3.4. Okay, and n is equal to the third orbital, minus 1.51 electron, so on. So here first already we know this orbitals k, l, m, okay, n, o. So these are the orbital numbers. So first orbital number k shall have, what is the energy here? The k shall have minus 13.6 electron volt. So L shall have minus 3.4 electron volt. Okay, next we will draw the energy levels diagrams of the hydrogen atom. Okay, energy level diagram of the hydrogen. So this is the energy level diagram of the hydrogen atom. So hydrogen atom. So energy level diagram of the, so first energy level minus 13.6, second energy level minus 3.4, and third level minus 1, so on. Okay, so here the radius the horizontal lines to energy scale, this diagram also known as energy level. We can draw with the circles or we can draw with the horizontal lines. Okay, so here we should remember 2 points are very important. First point, this first energy level we call as the unexcited state of hydrogen. Okay, this first energy level n is equal to 1 we call as the unexcited state of hydrogen, also called as a ground state. Okay, so also called as a ground state. So this is a first energy level or first orbital. Okay, so this is we call as a ground state or unexcited level. Okay, and so here these electrons are jumping higher energy level to lower energy. If we apply external energy to this atom, electrons are moving lower energy level to higher energy level, so automatically electrons are jumping higher energy level to lower energy level with the emitting energy. Okay, so here you should remember the first energy level you call as a ground energy level, ground state or unexcited state of hydrogen. Okay, some points are very important. First point, if we apply some energy, some photonic energy, example, if we apply 25 electron volts to this hydrogen atom. Okay, so if we apply minus 13.6 electron volt to this atom, automatically electrons are moving from this atom. But we apply 25 electron volt to this atom, so automatically just 25 minus 13.6, so we get the 11.4 electron volt. I mean, so electrons are escaping from this hydrogen atom with having additional energy 11.4. I mean, ikkada ఓన్లీ మనం 13.6 ఎలక్ట్రాన్ వోల్ట్ ఎనర్జీ ఇస్తే ఎలక్ట్రాన్స్ అనేవి ఫస్ట్ ఆర్బిటాల్ నుంచి బయటకు వచ్చేస్తాయి. ఐ మీన్ యాటమ్స్ నుంచి బయటకు వచ్చేస్తాయి. అంతకంటే ఎక్కువ మనం ఎలక్ట్రాన్స్కి ఎనర్జీ ఇచ్చినప్పుడు ఏమవుతుందంటే, సో ఇట్ గివ్స్ ద పొటెన్షియల్, it will gain the photon energy or kinetic energy. So it will convert to kinetic energy. Okay. And second point of this energy level diagram. So if we apply minus 13.6 electron volt, okay, so electrons are raised to infinity level. Okay, so if we apply 13.6 electron volt to this hydrogen atom, the electron observe this 13.6 electron voltage and rise it to infinity level. Okay, I mean electrons are free from the nucleus, so and it gets the kinetic energy. So this energy we call as the ionized energy. So this electron we call as is said to be ionized. So this is the ionization energy of the electron. The energy 13.6 electron volt is called as the ionization energy. Okay, ionization energy of the hydrogen atom. 13.6 we call as the ionization energy of the hydrogen atom. You should remember this point also. Suppose we apply 10.2 electron volts, so the difference between first energy level and second energy level, that is a 10.2 electron volts. Okay, if we apply 10.2 electron volts, so these electrons are jumping first energy level to second energy level. Okay, so first energy level to second energy level. Okay, so these are the important points from this energy level diagram. Once again repeating, if we apply excess energy to this hydrogen atom, so electrons are escaping from hydrogen atom as well as it possesses kinetic energy. Okay, so if you apply 25 electron volts, so but it require only 13.6 electron volts, but if you apply 25 electron volts, these electrons are escaping from this hydrogen atom, and so it gain the external energy, so that is 11.4 electron volt. If apply 13.6 electrons only electrons are escaping from this nucleus, so this energy we call as ionization energy. Okay, if you apply 10.2 electron volts, so these electrons are jumping first energy level to second energy level. Okay, so this is a information about the today's topic. Thank you.